Great.
Hello world, welcome to our webinar about Vaadin and Scala. My name is Henri Muurimaa and with me is Risto Yrjänä. Risto, can you tell us who you are and why are you here today?
Okay, hi, my name is Risto Yrjänä. I'm a Vaadin expert here at Vaadin, and I'm here because I'm one of the authors of Scaladin, a Scala wrapper for using Vaadin.
Great. With us is also James Ward from Typesafe. So, calling from Colorado. Good morning, James.
Morning. Thanks for joining, everyone.
Great. Can you introduce yourself?
Yeah, I'm a developer advocate at Typesafe and help developers learn Play Framework, Akka, and Scala.
Cool. As for myself, I actually run the services department here at Vaadin as my day job. But the reason why I'm here today is that I fell in love with Scala a couple of years ago. And since then I've been exploring how to use Scala with Vaadin and also trying to spread awareness of Scala within the company. So basically what I love about Scala is the functional aspects that let us express our code in a much more terse and nice way. So I think Scala has a lot to offer to a Java guy like myself. Actually, Risto, do you remember the first days about getting started with Scala?
Yeah, I do remember, and I remember that learning Scala and starting Scala development was definitely full of those really small aha moments where you learn something new about programming in itself and you kind of find new ways to do old stuff more effectively. It was really, really great.
Right, sounds really familiar. James, actually, do you remember the first time you actually wrote some Scala?
I do, yeah. I was at the Scala Summit up here in Crested Butte, Colorado, and with Diane Marsh and Dick Wall and Bruce Eckel, and they were really excited about this language that Dick had been talking about for a long time, and so we dove in and started writing some code. And I think my first reaction to it was there's a whole lot here that I don't understand, and so it was kind of a challenge for me to get into and get started with. But now I'm feeling quite comfortable with it a few years later. So now really enjoying it.
Sounds really familiar, actually. All right, so let's see what we have planned for you guys today. So we probably have a mixed audience coming from both Vaadin and Scala communities. So we try to give you both groups something. So we'll kick things off by a Scala introduction by James, right? Right, James?
Yep.
Great.
Yep, that's
and
right.
He promised to show us lots of live coding, so that's always a plus.
Yeah.
Next, I'll give a brief introduction to Vaadin itself and also say a couple of words about the Vaadin effort within the company. And then Risto will actually introduce Scaladin, which is the center of that effort, right, Risto?
Yeah, we'll have a few slides and also some awesome live coding.
Okay, cool. After the Scaladin demo, I have a couple of slides about reactive approach and Vaadin. So that might be interesting considering how Scala is in the center of, or at least one of the centers of the reactive movement right at the moment. We also have some interest from the community and the audience about using Vaadin with Play. So James can tell you a couple of words about Play itself, and then Risto have some stuff about using Vaadin with Play and how to integrate them and so forth. Yeah. Basically, that's it for today. So in the end, we have time for questions. So please add any questions that you might have during the webcast on the YouTube Live channel. So we'll pick them from there. But basically, do you guys have something to add at this point?
No, let's go.
All right.
Oh,
take it away,
good.
James.
Great. So I want to start with a quick little introduction to Scala for those of you that aren't familiar with it. And Scala is obviously a very deep and rich language, so I'm going to try to pick some of the features that you'll interact with most quickly as you're getting into Scala and give you an introduction to those. So first, the way that you'll get started with learning Scala and writing Scala is through a tool that we created at Typesafe called Activator. And Activator is your tool to get started with the whole Typesafe platform. So that's Play Framework, Akka, and Scala, and Slick. So you can just download that from typesafe.com, and you can use Activator both in a UI mode as well as in a command line mode. So I'm going to do it in the UI mode today. So to do that, I'm just going to launch Activator. So this will now start up a local web application. So today, Activator is a local running web application. So you download Activator, start it up, and then you can use Activator locally, but it is a web application and of course built with the Typesafe platform. So from here you can pick one of the many different template applications to start with. We have some featured ones here, and then you can go browse a community repository of templates as well. I'm going to pick the Hello Scala one, and let's put this on my desktop and then hit create. And so now we've just created a copy of this template application, and now we're in the Activator UI for this particular application. So every template comes with a tutorial, and you can walk through the tutorial and learn about the code and explore that. It'll explain to you the different parts of the code. And I'm going to minimize that because that's your homework for tonight, is to go through the tutorial. But there's a few different parts of Activator I want to show you. First is the code view. From here we can open up the code in IntelliJ or Eclipse, or we can just navigate through a little web-based UI for the code. So I can come in and open up this hello.scala file here and make some basic changes. This is just for basic code editing. For anything hardcore, you definitely want to go into IntelliJ or Eclipse for that. In Activator, we also see the compile output from compiling this application, the test output from running the tests, and then the output from actually running the application. So those are the main parts of Activator. Let's go back into the code view and let's start writing some Scala code. So the first thing that I want to talk about is immutability. So immutability is really one of the core parts and tenets of the Scala language. Really what it's helping us to do is write non-side affecting code and concurrency-friendly code. So in many programming languages, the default way to write your code is with mutable state. And the challenges with mutable state are, one, you can pass references to your objects and mutate them in places that make it hard to track down where the change is actually happening. And so that's side affecting code, is when you have a method that's operating and mutating state on an object that was defined outside of that function. And this really, I didn't realize the challenges with side affecting code until I got pretty deep into Scala and started just writing non-side affecting code, and really realized the benefits of writing your code in this way. It really makes it a lot easier to understand your code, understand where your state is being mutated, and so that was definitely one of the first parts of Scala that I really liked working with, was the immutability and the non-side affecting part. Another part of immutability is that when you have a concurrent system like we do with the JVM, you can very easily get into situations where different threads are trying to change the state of something at the same time. And that's one of the benefits of the JVM, is that we have threads and we have this shared mutable state in the JVM. It allows us to do some really interesting and high performance things. But the downside to that is that you can have different threads mutating your state. And so we need a way to deal with that in the new parallel world where we're getting more CPUs instead of faster CPUs. And so immutability is a core tenet of Scala. Let's just go write some immutable code here. So I'm going to define a val. A val in Scala is the immutable way to create something. So I'll call this foo, and it's a string, and we'll assign that to ASDF. So let's just go print out that ASDF, and then we're going to recompile that. And so we'll see the compiler run, the test rerun, and then we'll see the output from actually running the application, and then we see ASDF. So that's great. So now we have this immutable value, and this means that we can't actually reassign this now. So if I tried to reassign that foo to a different value, we actually see we get a compile error, and the compiler won't let us do that. And so that means that whenever we want to mutate something, we have to create a new instance. We have to create a new object. Of course, there is a mutable data structure in Scala. It's called a var, and we really tend not to use vars as much as possible because that leads to the side affecting code and to state that can be mutated across threads. So the one place where we do tend to use vars is there are obviously places in an application where you can't get away from mutable state, and so we'd like to put those inside of Akka actors, and that gives us a nice way to guarantee that only one thread is going to be mutating that state. So for most of our Scala code, vals are the way to define our immutable objects. So that's the first thing I wanted to show you with Scala is immutability. Now let's talk about type inference. Type inference in Scala is a way to really type less but still have type safety. So you'll see that I put the type information here on this val. I said it's a string, but the Scala compiler can actually infer that type. So I can remove that type information, and now the Scala compiler is going to look at the value and see, all right, that looks like a string, so now this is a string. So if I tried to perform an operation on this, I would be operating on this thing as a string. It is a string. But I don't have to always tell the compiler what these types are. So type inference can really be a way to make the code easier to read and write and make it so that the compiler is really doing more work for me, inferring these types. Of course, I can always be explicit about the types, and there are places where you should be, like in method definitions. You should always be explicit about the type that the methods take and the type that they return. And but inside of your code, when you're working with values, you can let the compiler infer those types. So likewise, if I was to change this to an int, then the compiler is going to infer that, and of course that's still going to work just fine, but now it'll be an int. So type inference is definitely one of the really powerful parts of Scala. Let me show you one more example of that. So if I want to create a list, and we can just say list 1, 2, 3, and then let's go print that. So now it's just inferred that this is actually a list of int. So the actual type here would be list of int. So, but I don't have to write that. I can just leave that out, and it's going to figure that out for me. So, and of course, that's going to work just fine. So let's say we now wanted to take this list and add a new item to it. I haven't specified the type of this thing. Let's create a new one. And I can now add a new item onto this list. So I'm going to do :+ and let's add a string onto this, and then let's output now that new value. So I've added a string into this list, and looks like it's all working correctly. But what's interesting is that the Scala compiler now has looked at this L, which is a list of int, and I'm adding a new string to it. So what this actually became is now a list of any. So it actually looked at those two things and said, hey, there's no correlation between ints and strings. So it had to go up to really the closest place where these two things had something in common, and in this case that's any, which is kind of like the top of the object tree in Scala. So if I did say this needs to be a list of int, then I'm going to get a compile error because I'm trying to stuff now a string into this list of int. It's saying, hey, you can't put a string into this list of int. So there's type inference, and really one of the great core features of Scala to help you type less and make your code more comprehensible. So one of the other great parts of Scala is case classes, and these are value objects done right. So let's go define a case class here. And a case class, what it is a really concise syntax for defining a value object, essentially. And these case classes have a bunch of features out of the box on them. So it's got this concise syntax, but then it has built-in methods for toString, equals, hashcode, extractors, creators, copy methods, all sorts of great features that come along with these case classes. So let's go create an instance of this foo. So I'm going to say val foo equals foo, and then give it a string. So this syntax here, let's print this out just so we can make sure that it works. So this syntax here is actually now creating a new instance of foo. So that's just like doing new foo. It's just a little convenience method where you don't have to put the new in there. I'll explain a little bit about how that works in a second, but let's make sure it works. So you can see there's our nice, pretty toString method that was created for us. So I can do new foo, that's fine. What's really happening when I call this foo with a parameter is it's calling a method on this foo object, and it's called apply. So whenever I leave off a method call, the Scala compiler is actually going to go looking for this apply method there when I use it in this way. So apply, if we actually looked at what's underneath the covers for this case class, apply is actually doing the new foo for us. So now this should work the same way if I call that foo.apply. So we'll remove that, go back to how we are. Another part of these case classes is that they're immutable. So I can't actually mutate the values inside of this case class. They're immutable by default. And so if I do want to mutate these values, the foo case class now has this nice method on it called copy. So let's create a new object here called bar, and I'm going to use that foo instance, and I'm going to call the copy method. And now in the copy method, I can provide override the different properties. So this is now an immutable way to create new instances with different values. So now I can print out both of these, and now we see both of those values printed there. So case classes are definitely a very powerful part of the Scala language. So then optional values is another important part of Scala. Really what this helps you do is avoid null pointer exceptions. So into the type system, we've encoded something that can be optional. So in Java, the way that you encode optional things is just to set something as null, and that leads to null pointer exceptions. So let's create a new value here that will be an optional value. So let's call this ASDF, and it's going to be a type of option string. And then in this case, I want to set this to be an actual value. So I say sum ASDF. So sum means that this optional value has a value. If I want to create one that doesn't have a value, then I would say none. So and then of course we can print these out, ASDF and nada, and remove that case class and save that. And you can see there everything works as expected. But the nice thing is that now in the type system we've encoded the idea of optional values, and we can even do things like let's do nada get or else, and this will say if that option doesn't have a value, then we can provide a default. And if we assign that to a value here and print that out, then of course we will see that there. Let's go run it, and you'll see that there's our value now. So that's the default value. So that's optional values. That's putting optional values into the type system so that the compiler catches those for us instead of having null pointer exceptions at runtime. So then the last feature I want to talk about is higher order functions. So I'm going to copy this code here in. And what a higher order function is, it's kind of a fancy word. What that means really is that functions are a thing. so there's something that we can reference and use just like we would use values. So I've defined a function here. In this case, it's string length. It takes a string parameter and it returns an int, and in this case I'm just calling s.length. Kind of a trivial example here. So now here's the cool thing about higher order functions, is that I can define functions that take functions as parameters. So here I have a string transformer which takes a string and then takes a function, and this function needs to take a string and return an int, and then this string transformer returns an int, and then I just call that function on the string. So now we can use this. Let's call the, let's print it out. So println our string transformer. And then in this case, we want to give it a string. We'll just give it ASDF. And then we need to give it a function that we're going to apply to this string. So in this case, I'm going to give it the string length function there. So that's going to satisfy this parameter, which is a function that takes a string and returns an int. And let's try this out and see if it works. So then you'll see we get back 4 because it ran that function on our string. So one of the very typical places that you'll use these functions as these higher order functions is with the map function or flat map function. And what the map function does is it will take the items inside of a container. So the container could be a list, it could be a future, it could be a string, it could be really many of the types in Scala have a map function on them. But what the map function does is it takes all the items inside of a container and it applies a function to all of those items. So in this case, I'm creating a list, and then I'm calling the map, and the map takes a function. In this case, the function I'm giving it is string length, and so it's going to then apply that string length function to each of the items in the list. So now let's assign this to a value, and let's print it out, and then we'll see what we get. So we'll save that. And then in run, we see that what we get back is a list of 1, 2, 3. So for each of those strings that were in the original list, I ran that string length function on it, and so then I got back a list of 1, 2, 3 because that was the length of each of those items inside of the container, which in this case was a list. So then let's talk about anonymous functions. So the syntax where I'm passing these references to a function around, there's cases where you want to do that, and then there's cases where you don't really need a reusable function. And so what I can do is, let's do the same thing here with our map, but instead of passing it now a reference to a function, I can do an anonymous function. This is very similar to a Java 8 Lambda. And so now I say S is my input into this function, and then what I'm going to output is s.length. And so this is the function now that I'm applying. So this is an anonymous function that I'm applying to each of those items. And let's print that out. And then what we should see is the same thing, but now it's using that anonymous function rather than the predefined function. So this just comes down to, are you going to reuse this function that you're putting into the map or not, whether or not you use anonymous functions. So that's it. That's the main features that I wanted to cover to get you started with Scala, get you an idea of the basic features. To learn more, check out Typesafe Activator, pick from one of the many templates in there to get you started. And then a great book for beginners to Scala is Atomic Scala by Bruce Eckel and Diane Marsh. Really starts with the very, very basics and is really a nice way to get into Scala and not be instantly overwhelmed with things like monads and applicative functors and the crazier parts of Scala. So check out Atomic Scala. There's free, I think 50 pages or something of that book available, and then all the sample code for that book is available in Activator. So there's your introduction to Scala. I'll pass it back.
Thanks, James. That was great. And from experience, I can say that you just scratched the surface there. So there's lots and lots of really cool and interesting stuff behind the scenes. Okay, so before we actually go deeper into Scaladin itself, I thought that I would give a brief introduction to Vaadin itself for those who are joining us from the Scala side. So I'm reusing a set of slides here that is from our generic introduction presentation, but I'll skip most of the slides and concentrate on architecture and bigger stuff like that. You can actually find a link to the video of the talk in the YouTube comments afterwards if you want to actually see the whole talk. But alright, so first of all, Vaadin is the Finnish word for a reindeer, and you can actually see the reindeer in our logo, so there's horns there as well. But today we are talking about Vaadin, which is a framework for building rich web applications. And I'm differentiating applications from web pages here. So if you want to do like next Wikipedia or something like that, which is mostly read-only, then Vaadin might not be the best option for you. Vaadin is actually a set of UI components. They're rich components with lots of features, and you compose your UI using those in the server side. So if we differentiate this from the other normal way to construct your UI, we can see, for example, if you have a JavaScript-based UI or a Google Web Toolkit-based UI, actually. You have this backend server that contains database and services like that. Then you have this web server, which takes the requests and returns something from the user. You need a communication layer that allows you to talk to the browser, and of course you need the actual UI done in JavaScript, or in case of Google Web Toolkit, or actually it's GWT toolkit nowadays, which is basically a compiler from Java to JavaScript. But anyway, you need to implement that as well. So this is what you need to do in a scenario like this. Whereas with Vaadin, we are talking about server-side UIs, which means that actually the amount of things you need to do is smaller, because Vaadin will allow you to actually do whole UI on the server side, and Vaadin itself will give you everything needed to actually render a nice looking Ajax-based UI in the browser. And if we ignore the backend server, which can be identical in all cases, we can see that there is quite a bit of less blocks required for a Vaadin-based UI. So the value proposition is, of course, that less code is needed, less maintenance, less technologies, and it's easier to learn as well. At least if you're coming from the server-side Java world. And other nice things about Vaadin-based approach is that since we are running in the server side already, we can use any JVM language. And of course, today we are talking mostly about Scala, but there are plugins and extensions for Groovy and Clojure and JRuby and so forth. Vaadin UI works on all browsers, including mobile ones. All backend platforms are supported. All IDEs, there are plugins for all of the major ones, and also you can use in the Vaadin application itself any backend technology that you want. This is simple because your UI is running in the same place where your backend is. I mentioned mobile. We have this commercial product called TouchKit, which gives you a nice looking UI in your mobile touch devices. And also we have an add-on for creating responsive UIs, which means that it's easier to compose a similar UI for any terminal or screen size. It's also quite extensible, and there are lots of different add-ons available in Vaadin directory. Actually, we are going to talk today about Scaladin, which is actually one of those add-ons. Going to the UI itself, Vaadin supports Sass out of the box, which is quite a bit nicer way to compose those themes and lookable stuff in the browser than plain old CSS. The default look and feel is quite nice. We actually put quite a bit of effort to make it as nice as possible out of the box, but it's also extensible, easy to build all kinds of different themes and look and feels with that. On the back end, we have a server push capabilities with one simple annotation. Actually, I think Risto is going to show that with Scaladin as well. And one important thing that people many times ask, so can a server-side technology scale? So for this reason, we created this fixes ticket sales system, deployed that to Amazon Cloud, and tried to break it with JMeter tests. So to get us some numbers how Vaadin can handle load. And there's actually a link that you can find more and actually recreate our test yourself if you want. So test results were that the server was able to handle more than 20,000 AJAX requests per minute. This means on the fixed ticket sales systems 5,500 tickets per minute, which means around 11,000 concurrent users. And this was done on a single Amazon EC2 large instance. And numbers are nice, but put that in a perspective, it means that in 2009, this is about double that the MPAA reports that there were sold tickets in the whole US. Of course, this is naive comparison because this doesn't account for peak hours and so forth, but still gives an interesting insight on how this one server can handle load. And again, this is one server, so if we go up, we can see that adding more front-end servers on the same backend actually allows us to scale the whole system quite easily. So there was this link in a couple of slides back, so please read the blog post if you want to know more about that. And if you are interested in Vaadin itself, it's really easy to get started. We have nice tutorials and other stuff available at vaadin.com/learn. Just grab the plugin for your favorite IDE and get started. There's a book, free, over 700 pages. Again, something that we try to concentrate on because many open source projects really don't have nice documentation. We try to be the one that has. We already have quite a nice sizable community which can answer your questions at vaadin.com/forum. Actually, the forum software itself is something called Tori, which is built by us, and we tried to make the nicest forum software available. And there was a question from the audience that what does it cost? Vaadin itself is Apache licensed, and as is Scaladin, so it doesn't cost anything. Just grab it and get started. All right, so that was a really short introduction to Vaadin. So let's go to the actual topic of today. So Vaadin and Scala. The point here is that we at Vaadin really like Scala. So several of our team has participated, for example, the Coursera Scala courses, and we have, I think, dozens of people with top marks from both courses. So we really like it, and we already have tried to create some add-ons and other things to support the Scala community to use Vaadin. And the main thing on that effort is, of course, Scaladin itself. So Scaladin is a wrapper over Vaadin components, but trying to recreate a more functional API over those components. And Risto will tell us more about that in a minute. But as James said, Typesafe Activator is a really nice platform for creating showcases and even experiment with. And we have, as of a couple of days ago, we have 2 templates for Vaadin in the Activator available as well. So how about Risto, you take it from here?
Okay, great, thanks. So like Henri mentioned, Scaladin is really a wrapper around Vaadin. It's a way to use Vaadin in a Scala environment more easily. So of course you can use Vaadin in any JVM language, but with Scaladin it's more easier and the API is more familiar to you. So how we did it, we simply wrapped the Vaadin API with Scala classes. So what happened was that we took the UI components, we took some server-side stuff, so UI providers and all that, and we simply provided Scala versions of those. So let's see a quick example. So here's a button. So it looks quite much like the Vaadin button. It extends abstract component as the Vaadin one, but you'll see that inside it is actually the real Vaadin component with a special mixin that helps us recreate the hierarchy. And you'll also see that we map the functions, so everything you can do with Vaadin components you can do with the Scaladin ones. So for example, a button behaves exactly in the same way, but we get the nicer properties of Scala, so we can just create write button, disable, on, click, true, and so on. So this is the hierarchy, so we have recreated it completely. And let's look at that table in a bit more detail. So this is normal Java Vaadin code. So this is something you would write in any Vaadin application. And this is okay, but this is what it would look like in Scaladin. So it looks a bit more nicer. You get rid of the value change listener, and one way to make it even more nicer is to kind of model the hierarchy. So this is a way to make your code more readable. When you create larger UIs and larger components, using this kind of hierarchy makes the code more readable, and you see what's inside what and so on. And this part, for those coming from a Vaadin background, might seem a bit odd, but as I explained previously, this is just a function from the event to some value, and this is actually the value change event that you see in the Java code. And if you don't need this, you just want to do something when the value changes in the table, you can remove that. Let's look at a more complex example. So here in the UI, we have a table, a layout, and then a button below the table. So again, in Vaadin code, just to remind those from a Scala background, this is pure server-side code. So we have a layout, some properties, we have the button, table, and we add the table and the button to the layout. Now again, in Scaladin code or Scala code, this is more compact, and it also reflects the hierarchy better. So you can easily see that there's a vertical layout, and inside that is the table and the button. That's about it for the brief introduction, and just as a reminder that there's a simple build tool plugin by Henri for Vaadin. It does the usual things that Vaadin plugins usually do, so it helps you build a widget set, run dev mode, and so on. But let's look at an example. Actually, we could quickly show you the Typesafe activator templates we have available. So if you take the activator that was introduced and search for Vaadin, there's the reactive stocks with Vaadin. So that's a template for interacting with akka from a Java application, and then we have the Scaladin template for starting Scaladin development, and that's what we're going to use now. But to save time, I've applied that, and here in IntelliJ I have the project. So I've made a few changes. So one is to include the Vaadin push, because we're going to use that later, and the other one is to include akka. So akka is an actor-based library in the Typesafe stack, which is briefly to use the to create like concurrent applications easily. So I've also added a chat.scala, which is basically a chat client. There's messages you can send, and it propagates those messages to all the listeners, so basically all the people in the chat. And in the end, we have the very small Scaladin UI. So this is a very typical hello world in Vaadin. There's the UI, and then there's the button that shows a notification. And we can just quickly check how that looks like. Yay, seems to work. So let's get started. So I think that for a chat application, we can at first just replace the content. So we'll create a new vertical layout, like so. And inside that, we probably need something to display the chat messages. So let's create a table. So new table or something, and we can right away add that to the layout, like so. Add a new table. Let's make that full size, like this. And also make this full size, so they fill the whole browser window. And then below the table, we probably want a way to send the message somehow. So let's put a send button and a text field. So again, we'll add a new layout called horizontal layout, like so. And to this we can add, let's say, new text field, like this. This could be a bit wider, so we can say width 100%. And in addition to that, we can add the button. So let's again add new button and give that the caption of send, like this. So now we should have a vertical layout with the table, horizontal layout with the text field and the button. So let's see how it looks like. Okay. It's good. So we have the table, we have the field here, so let's move on. One thing we can do is we can expand the table a bit to fill more space. So we can call ratio is 1f. So this is just a way the component takes free space. And then we can make the button maybe do something. So we would like this to now send messages to the chat client, or the chat actor actually. And for that, we'll make this UI extend or mix in actually the chat client mixin. And from that we get one method, which is the onReceive. Okay, now this is a chat client. And on the button we can say click listeners. So these are invoked whenever the button is clicked. And over here then we can send a message. So in order to do that, we need to name this. So message field, and then just call message field oh, sorry, my bad. Probably not the horizontal layout, but the text field. Better. Okay, message field value, it's an option of string, so it's either some string or none. So we want the value, so we can use the get or else method that was introduced. So we either get the value from the field or an empty string, and we can just send that to the chat actor. So chat actor ref, so this is the actor reference, and create a new message. So message, like this. And this also requires a this reference, so we'll get that from over here, like so, and should be good. Okay, we can send messages. What else do we need? So we need a way to log in, so we know what users is logged in. So we'll do it really quickly. So to the topmost layout, so this vertical layout over here, we'll just add a new button. So new button, and let's say this is a login button, and again click listeners, we add a new click listener, and when this is clicked we send a login message. So that's to the chat actor ref. Let's add or send the chat actor login message, which again takes app and then some username, and we can just quickly add some random string for it, like this. And after that we can probably just disable the button. So from the event we get the button and we can set enable to false. Okay, now we can log in, we can send messages, and now we need a way to receive chat messages. So a way to do asynchronous updates to a UI in Vaadin, the best way to do that is to use the access method. So we can just write access, and inside that we can modify the UI freely from another thread. So in this case we would like to add a message to the table, but the table is quite empty right now, so let's fix that. Take the table out, call it messages, and put it somewhere over here, like so. So it's full size, but in addition we probably need at least a few columns. So in Vaadin UIs, those are container properties. So let's say user, and the type of the column is string, and default value is none, and then put the actual message there. Okay, now we have the table, it has the properties, so the columns defined, and now here we can take the table, messages, and add a new item to it. So that returns us the item ID, and with that we can get the actual row, so we can update the values. So we'll say messages get item with the item ID, get property, so this is now the column, so it was user, and that's value we can set to the username that we got from the actor, and then just do the same for the message. Okay, now we have 3 steps where we interact with the actor. We log in when we click the button. We have the send button, which sends the current value of the message field, and we have a way to receive messages and apply those asynchronously to the UI. And all we needed to do for the UI to be push enabled was this push mode here, and then the dependency to the Vaadin push jar. So let's see how that looks. Refresh. Okay, seems good. We have at least the login button. Okay, now we're logged in, and let's see if we can send messages. Okay, seems to work. We can make this nicer, and what we could also do is to test this in another browser, because the chat actor is the same for all UIs. So we could, for example, take Safari, go to localhost, log in, and send the message, and it's automatically displayed and pushed to all the UIs who are now in this chat. Okay, There's some tricks we can still do to make this nicer. So one is for the button to have a shortcut. So click shortcut, we can set that to a key shortcut and say key code enter. So now this button is clicked when the user presses enter. That's a nice way we can make the text field be a bit wider. So, oh sorry, not wider, but to act when there's something in the field, and then make this button be enabled. So we can start by setting this enabled false, and then we can add a text change listeners like so. So these are invoked every time the text actually changes, and now we'll have to name the button like so. So we have the send button and type it, but after that we can say that send button enabled is equal to the text value of the field, or if there is text or if there isn't. So is empty and like so. So whenever the text field isn't empty, then the send button is enabled. Okay, let's see how that works if the server has restarted. Okay, this is disabled, and we should get okay demo effect here. Let's see. Should be okay. Oh, might have some combination errors. Okay. Yes, looks better. Let's see. Let's look in. Say something, and now the send button activates, and by enter we can send messages. There's a lot to do, so we could implement a prettier login, pop-ups and all that, but I think for this time, I think this is now a good demo.
Yeah, that was actually pretty cool, so thanks for that, Risto. And again, of course, we just scratched the surface here, so lots of other stuff available here, but still nice to see the push mechanism in action and so forth. So what did you, James, think about that?
That's awesome stuff. Yeah, really looking forward to using it. It's building UIs is traditionally such a pain, dealing with all the browser quirks and stuff, so that definitely makes life a whole lot easier.
Yeah, actually, I remember one of our users commenting Twitter or somewhere that they were not, when they were building their application, they were not targeting IE6 at all, but because they were using Vaadin, it accidentally works perfectly on IE6 as well, so that's great.
Nice.
I have to say,
Awesome.
however, that Vaadin 7 doesn't support IE6 or 7 anymore, only 8 and up, but Vaadin 6, which is still quite usable, supports those as well. All right, so I think we are running a bit late here, so let's try to be fast. Next thing I wanted to mention was something called reactive extensions to Vaadin. So, James, could you actually introduce the concept of reactive programming?
Yeah, sure. Reactive programming is really taking some old ideas and bringing them mainstream. So the Reactive Manifesto is where we and some others have outlined some of the ideas of reactive. But ultimately, what it's about is creating software that is reactive to users or reacts to users, called responsive is the trait, reacts to load, and that's scalable, reacts to failure, that's resilient, and then that's all based on a foundation that's event-driven, so it reacts to events. And so there's a bunch of different ways to implement reactive, but the important thing is that reactive it's nothing new. It's the event-driven architectures that have been around for 30 years with Erlang, but now these programming models are becoming mainstream because the tools and libraries now are able to help developers like me do event-driven programming.
Right. And actually, one of the important things that, at least one of the things that sold me on the idea was that when you go from event-driven UIs like Vaadin into being able to compose the logic by getting the input from the user in a form that is composable, it actually makes the UI code itself and building the UI logic much nicer. And for this, and actually I built a really quick proof of concept, let's say, to trying to convert the events coming from Vaadin, because Vaadin itself is event-driven framework, in a way that allows the programmer to work them in more functional way. And for this end, I built something called Reactive Vaadin. This is actually based on the Reactive Java library by Netflix, which is really nice stuff. You should totally check it out. And well, basically the idea is that Reactive Vaadin and Reactive Java actually gives us something that's called an observable. And this is basically a value that can change over time, and you can take the observable and perform functional composition operations on that. And Reactive Vaadin then takes the event streams from the Vaadin components. Basically everything that is a field behind the scenes is also a value change notifier, and we can convert those into an observable stream of values coming from the UI components. And getting the actual values from the UI is nice, but if you can't push them back to the UI, it's useless. So we can also connect an observable into a Vaadin property, which is basically another category of components that display values on the UI. So really quick example, this is Java, but similar approaches available on Scaladin as well, of course. But the point here is that this is a small part of our example application, which gets one label that we want to modify and a couple of observables that are composed from the other UI components. Basically, we first do something for the score to get a string of scores, and on the middle there we call reactive.follow to connect the label component into the observable directly. This means that whenever a new value comes from the observable, then the value of the label will change. And also, second bit of API in Reactive Vaadin is that we can set the same component to clear whenever a second observable emits a value. So this is actually was, to myself at least, a nice experiment on how to build UIs in any way. Reactive Vaadin itself is available on GitHub and as a Vaadin add-on, but I had to say that this is just a weekend project, and the API is highly experimental and probably will change a lot before it's actually usable. All right, so next up on our topic list is how to integrate Vaadin with Play. We have actually received lots of questions regarding that, and so James, could you actually start the discussion by telling a bit about Play itself?
Yeah, so Play is a web framework for Java and Scala. It's a stateless web framework, and obviously in applications we sometimes have state somewhere, and so when paired with the Akka actor model, we actually have a really nice place to manage state in our applications. So so Play and Akka can be paired together very well, and Play framework, there's a lot of templates available in Activator to get you started with Play. One of the core features of Play is a just hit refresh model, where to see your changes you just hit refresh in your browser. There you see your compilers, and then if there's no compilers you see the new version of your application. So really creates a really nice smooth development cycle where you don't have to be restarting your container to see your changes.
All right. So as I understood, I actually really know next to nothing about Play, but I understand it works something called Neti, whereas a Vaadin application is actually a servlet behind the scenes. So it's not straightforward to use them together, but luckily Henri Kerola, who is actually the second author of Scaladin, has created some piece of integration code to make us be able to connect Vaadin and Play UIs. So Risto promised to actually show us a bit about that. So
yeah, sure. I'll quickly go through some slides about the integration, and I think it's nice to start out with this. This tweet seems to me like radically opposite approaches to. So that's what they are, but I think they can still complement each other quite nicely, and in the end I think that Vaadin and Play answer different questions and can really benefit from each other. But let's see. So in Play we have a Scala core, and in Vaadin a Java core, but we have wrappers in both ways, so you can use Play easily from Java, and with Scaladin you can easily use Vaadin from Scala. And the server foundation is also a bit different. So as Henri mentioned, Vaadin is typically deployed in a servlet environment, whereas Play framework uses Neti. The build system is a bit different. So Play uses simple build tool, and Vaadin really doesn't have an opinion on that, so you can easily use it with any of the popular tools. And of course the stateful versus stateless argument is pretty strong. Usually people talk about scalability, but as Henri mentioned, Vaadin still scales pretty nicely, but in the end it still is a stateful framework, and an application is always tied to an HTTP session. Whereas Play is RESTful and really designed to be very highly scalable, and yeah, let's continue. So the browser and server models are also a bit different. So with Vaadin you have the UI components on the server side, and then there's the client side engine that basically renders the widgets and handles the interaction. And with Play we have controllers and templates, and then there's the HTML produced from those, and that then interacts back with the controller on the server side. Typically there's also some JavaScript in the browser with Play too. If we look at a very simple hello world, so in Vaadin this is pretty much as simple as you can get it, but it still works, and this is the typical way to start a Vaadin application development. So the mapping is in the servlet definition. So in this case we're using server 3.0, which allows us to do the configuration in Java. And in Play we have routes, controllers and views, which define where the application is found and how the requests from the server client side are handled. And then client-side development with Vaadin, you almost always write Git code and rarely JavaScript, and with Play you use CoffeeScript and maybe some JavaScript on the side. With the look and feel, again, a bit different technologies, so Sass on Vaadin side and less on the Play side. And with these kind of all these differences, it kind of might seem like a daunting task to start combining these, but luckily it isn't that hard. So there's kind of two options we can go through here. One is to use the servlet base for both. So there's a var plugin for Play, which allows you to deploy Play applications in a servlet container. So that's one way, depending on your use case. Then the other way is to actually embed a Vaadin application inside Play. So then you use Netty, develop the Play application as you usually would. You just have one additional kind of URL inside, which is the Vaadin application. And this is the integration that Henri mentioned. So Henri has written this really cool integration that allows you to use Vaadin in Play applications. So there's a lot of use cases. So one kind of obvious one would be to use Play for static pages. Obviously you could use JavaScript there, but we're talking about more like web page, web application difference here. And you can also, of course, embed Vaadin UIs inside Play pages, so they need to be different URLs or completely different parts of the application. You can easily have one small part being a Vaadin UI and the other parts can be Play pages. And here are some examples on how you could do the separation. And the most interesting part, how do you actually use it? So let's see. Okay, something weird going on, but basically you just have a build SVT where you add dependencies for Vaadin, of course, then for Scaladin, and then for the Play Vaadin integration. And then you just, in the global settings of the Play application, you mix in the Vaadin support here. And then you write your UIs as you would normally, so nothing special there. So the Vaadin coding itself stays the same. And then in the application conf, you configure the path and what UI that responds to. That was about it. I encourage you all to try out Henri Kerola's integration and start kind of enriching your Play applications with Vaadin UIs.
All right, Risto, thank you. That was really interesting. And
that's awesome.
Yeah, and I understand that all that is available on GitHub. So
yeah.
We'll post the links on the YouTube channel after this webinar. So that's basically it. Do you, James, have something that you would like to mention at this point?
No, that's great. Check out the templates that have Vaadin in them in Activator.
Totally. Yeah, and I just got the message that we don't have any questions right now, so basically that's all we got. Thanks for joining, James.
Yeah, thanks for having me. That was awesome.
And thanks for our audience for watching, and hope it was really interesting for you, and hopefully you get much value out of Vaadin and Scala and Scaladin, of course. I hope you join us for your next webinar this Thursday, actually. The topic of that webinar is hybrid applications. So thank you and bye-bye.
Bye, thanks.